Hey everyone, your DNA replication notes will be done in 3 parts. In the first part of the DNA replication, we are going to talk about the formation of the replication bubble. So remember that DNA is normally a twisted ladder, a double helix, with the anti-parallel strands connected or oriented with their nitrogenous bases towards each other. And so these lines represent the A's, the T's, the C's, the G's that would be found in the DNA, and then the bonding, which is hydrogen bonding, that holds them together. So the first thing we're going to need to do to start DNA replication is to create this replication bubble. And we're going to do that at the origin of replication. This is where we're going to start this process. This process is just a segment of the DNA itself, and this is the code for where we are going to begin this bubble. At the origin of replication, this is where we're going to open this up. We're going to bring in proteins, we're going to bring in enzymes to help create this replication bubble where DNA replication will take place. Our first enzyme we're going to talk about is helicase. So helicase is an enzyme that breaks those hydrogen bonds between those nitrogenous bases, and it's going to work away from the origin of replication towards this area right here, which is called your replication fork. So helicase will be breaking those bonds, and not only will it work from the origin of replication in one direction, it'll also work in the other direction as well. So we're going to have 2 replication forks, and this concept is just called bidirectionality, meaning 2 directions. So replication will start at your origin of replication and occur in both directions towards each expanding fork. Not only are we going to have the enzyme helicase involved in the formation of this bubble, but we're also going to have single-stranded binding proteins. And what they do is they stabilize the bubble, because if they were not present, DNA would eventually recombine back into a double helix, and we don't want that to happen. We want this strand to be completely independent of this strand, so we can come in here and add a new anti-parallel strand on this side and a new one on this side. So by splitting these in half, we will end up with 2 strands of DNA, so we got to keep them separated, and we're going to do that using these single-stranded binding proteins. As the DNA is opened up by this helicase, as this replication fork continues, further down the line, further down the DNA strand, you're going to start to get supercoiling that occurs here as a result of the opening of the replication fork. So another enzyme called topoisomerase is going to come in here and help to relieve that tension. It'll help prevent the supercoiling from happening. Once we have done that, and we're going to have stabilizers of single-stranded binding proteins on all 4 sections, we're going to have even more. We have created our replication bubble, and now we're ready for the second part of DNA replication, which is the actual copying of the DNA, and we're going to do that in the next video.